Hello, hello.
Hi, Miss B. Good
Hi,
afternoon.
hi, can you hear me?
Yes, I can hear and see your screen.
Okay, we're gonna begin just now then.
Okay.
All right, so as we know, y'all ready? Just type ready so that we could get. I don't think a lot of people come in today because a lot of persons can't make it on Tuesday. So we're gonna get started, okay? Now, question 6 has to do with measurement. And so the formulas that we're gonna be talking about deals with the what you call it, area, perimeter, um, stuff like that. So I think we would have gone through those things. Remember, we did all these formulas. So I just want to quickly just scan through it. So we know area, perimeter is distance all around. When it comes to a triangle, there are three formulas that we learned. We learned the formula for trapezium, area for a circle, same thing with a kite. And then we looked at the sector, the area of a sector, the area of a segment. We looked at the volume of all specific 3D shapes, which we call prisms, how to find the area. And we did the surface area of some 3D shapes as well. And then we did some practice questions, right? So what we're gonna do, we're gonna begin looking at questions that make use of this content, okay? Just making sure everything else. So today what we're gonna use the FastPass notes, and we're gonna just go through the workings and make sure we understand what they did, how they're doing it, okay? All right. So let's look at the question, and what you should mentally prepare yourself is that they're gonna give you some object. So I'm gonna read through and you're gonna follow with me. And anything that you don't understand clearly, let me know. At a track meet, a cylindrical container fitted with a piece of pipe, as shown in the diagram below, is used to serve water to athletes. And in other words, this would be like a water cooler, right? With a pipe. The cylindrical container of a radius 12 centimeters, which is represented here in the diagram, and height 20 centimeters. And always remember, when you read this, make sure that the data is represented on the picture. If it's not, you write it in, okay? So it says here, the cylindrical container of the radius 12, blah, 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 is completely filled with water. So these are some things we need to pay attention to. It's completely filled with water, and the pipe fitted at the bottom dispenses water into a cone-shaped cups, right? The cone-shaped cups has a radius of 3 centimeters and a height of 8 centimeters. So what we've noticed, what I would notice is that the measurements for the container is the same thing as the measurements for the cup. That does not be the case all the time. So these are things you look out for. Okay. So let's read the first question. The first question says, calculate the water, the volume of water. So let me underline this. The volume of water in the cylindrical container in liters. Everybody see that? In liters. Write your answer, correct it 2 decimal places. And look at what they gave us. Luckily for us, they gave us the conversion, but last class I gave y'all this as well. Y'all remember that? Where we was dealing with the milliliters and centimeters cube? No. Hey guys, you hearing me? It's the weirdest thing when Google Zoom does this. I don't know. It's like you realize every first couple of minutes in class it is just shut down and come back up. It's weird. So let's jump right in. Y'all seeing, right? Y'all seeing the screen? All right, so let's go to the question. So here we see they ask us for the volume of water in the cylindrical container. So we know when it comes to volume of a cylinder, what is the formula for that? Volume is equal to the area of the cross section times what? Because this is the same thing that keeps coming over and over, times the height of the container. Yeah? And what is the formula for the area of the circle? Pi r square. So essentially the volume is equal to pi r square times h. So everybody following me so far? So this is a basic thing, to be honest. So far, this is basic. It looks scary, but it's pretty simple. So I'm just going to go over to the working because like I said today, I'm just going to allow us to read through the notes and follow and understand what we're doing. All right, so as we see here, all they did is the same thing, pi r squared h, which means pi r squared times h. So all we need to do is substitute. We know the value of pi is 3.142. Remember, I always tell you guys use 3 decimal places. We know that r, they gave us r from the picture. R is the radius and r is 12 and h is 20 because they gave us that. So it's just substitution calculating. So when you get your answer, obviously your answer is going to be in what? Centimeters cube. Everybody with me so far? No problem. So you have to go back to the question. The question says to express your answer in liters. So we need to convert centimeters cube into liters and look at it. How many centimeters cube make 1 liter? 1,000. So it means then that we have to do what? We have to divide our answer by 1,000. And to be honest, we don't even need a calculator because we know what do we do in a case like this? We move the point 3 times to the left. So you go 1, 2, 3. So that's how they get 9.048. No, they ask for your answer to what? 2 dp. So this is just rounding off. As you know, you cut off because this number is greater than 5. This number is going to go up by 1. So that's the answer. How was that one? Pretty straightforward, right? All we had to do was find the volume of the container holding the water. So let's look at the second question. B, water flows from the cylindrical container along the pipe into the cone-shaped cups at a rate, okay, this is something new, relatively new, let me say, at a rate of 7.8 milliliters per second. So rate R, you see, you could create your own formula. Rate R is equal to milliliter per, and I taught y'all this. What does per mean? Per means to divide per second. Everybody following this so far? And we know, what does milliliter represent? Milliliter represents what? Volume. And what does second represent? Second represents time. So to find the rate, it is really you dividing the volume by the time. The volume is measured in milliliters and the time is measured in seconds. So let's take a pause right here. Everybody with me so far? Niall, I know you're joining late, but let me know if you're following on how to generate your formulas, because we did this previously, but you know. Niall, are you there? All right. So let's continue. Now that we generate the formula here, the rate, they ask us to, let's look at what they ask us for. So let me reread the question. Water flows from the container, the one that we just calculated, along the pipe into a cone. So you see what shape it is? Cone-shaped cups at a rate of 7.8 milliliters per second. Again, what we just did just now was generate our formula to find the rate. It is milliliter per second. So that means milliliter divided by seconds. So question asks, calculate the time taken to fill one of the empty cone-shaped cups. Give your answer to correct to the nearest second. Now, because they ask us for time, what do you think we're going to need to do for this formula here? Shouldn't we transpose this formula to find how to calculate time? And you see why I did this even before I calculated anything? So we knew we don't generate the formula and always do that first. Rate is equal to volume over time. And we know what are the measurements or the units for volume. The units for the volume is what? Milliliters. And the volume for time is what? Seconds. Now, just look at this formula here in the box. How do I make time the subject? Anybody remember what do we do to make time the subject? We transpose, yes. But what is the shortcut? Because we want time and time is in the denominator, what we will do is just switch time and the rate. So time is equal to volume over the rate. Agree or disagree? So let's look at where we get the information from. So let's go back. They ask us to find the time it takes to fill up one of the small cups. Agree or disagree? So that means all the information we're going to be using is the information around what? In the cup. So if we're going to use a volume, which volume we're going to use? We're not going to use the volume of the big container because that's not what we're filling up. We're finding the volume of what? In the cone cup. No. Look at what they gave us here. The volume V of a cone with radius R and height is V is equal to 1/3 pi R square H. You see, they give you the formula. That means CXC was feeling very sorry for people. They don't usually give you this formula. That's one of the formulas you should try to memorize. Even though I think it's on the formula sheet, I have to verify. So let's go. We could calculate the volume because did they give us the volume? Look at the picture. Did they give us the volume of the cup? No. But what did they give us for the cup? They tell us the radius, which is what? 3, and the height, which is what? 8. So guess what we got to do first? We got to calculate the volume of the cup. And look at it here. Here, we need to first calculate the volume of the cup. So when you substitute, R is 3 and H is 8. So you plug it in, you calculate it, and this is going to be your answer. So let me pause right here and make sure everybody understand what we're doing. Everybody see how we found the volume of the cup? And in this case, it was easy because CXC gave us the formula. Okay? So when you find the formula, what do we do now? That was not the things they ask us for. They ask us to calculate what? The time it takes to fill one cup. So we done figure out the formula. You realize they did not give us this formula. That's the most important part. Everybody realized they didn't give us this formula. We had to generate this formula on our own. So we continue. So volume, which is what we just calculated, divided by the rate, and they gave us the rate. Look at here. It takes 7.8 milliseconds per milliliters per second to fill up the cone. So looking at the working, look at what we have here. And as you see, did they give us the formula? No, the formula was volume divided by time. Sorry, not time, rate, because it's time we want, rate. So once you do that, you get your answer. And then you see what they ask you for, correct to the nearest second. They didn't say second point something. You have to round it off to the nearest whole number. So that's how they got 10 seconds. So let me see. We only got one more part for this question and then we're moving on. So for those who joined late, I know it may be a little confusing because we almost finished the question, but just follow as much as you can until we get to another one, okay? All right, so let's look at this. Determine the number of empty cone-shaped cups can be completely filled with the cylindrical container. That wouldn't be common sense. How do you find out how many small cups could get from this big container? What is the operation? You don't divide the volume of the container by the volume of one small cup. So you could see how much small cups you could get. So that is the last thing. The number of cone-shaped cups that can be filled is the volume of the cylinder divided by the volume of the cup. So that was our first experience with a question 6. And now that we're going through it, it's not really that hard, to be honest. It's just overwhelming for students because the image is a bit complicated. But honestly, the questions aren't that hard. So let's move on to our next year. And honestly, this question is short too. These questions are so short. I was going through it and that's it. That's another year. That's another year. They aren't as lengthy as other questions, but just trying to make sure you understand. All right. So if you're ready for the next question, just say ready and we're going to keep it moving. Today's class is going to be shorter than usual. All right. So let's take a look here. And before we even look at the question, you should make sure you understand the image, right? Look at what you're seeing. Okay. So it says here in this question, take pi to be hello? You can hear me now? All right. So as I was saying, what you realize here is that they always giving you 2 different pi's to use, right? So sometimes they could give you the fraction form, which is 22/7, and the other time it could be 3.142. If they don't tell you which one to use, which one is the smarter one to use, the fraction or the decimal? The decimal, right? Because it's something that you could easily put into your calculator. All right, so let's go through this one. The diagram below shows a rectangular tank with base 50 centimeters by 40 centimeters that is used to store water. The tank is filled with water to a depth of 15 centimeters. Anybody realize what information they did not give us? Just looking at this, it doesn't stand out to me. They didn't give us one of the dimensions of the tank. Which dimension of the tank they did not give us? Because these are things you should notice too when you read questions like that. Anybody know? They gave us the width, they gave us the length, but what did they not give us? The height. Everybody agree or disagree? Because these are the things we need to be on the same page with. Y'all with me? The only thing they gave us is the height of the water in the tank, not the height of the entire tank itself. So let's look at the first question. A, calculate the volume of the water in the tank. That's easy because what do we know? Because it's a rectangle, we know volume is equal to what? Length times base or width. It doesn't matter. Width and base is the same thing. So length times width times height. In this case, length times base times height. Everybody with me? And we know these are the dimensions 40, 50, and 15. That's an easy thing, isn't it? Boom. And one of the most important things is our units. So it's going to be what? Centimeters cube. If everybody got it, say got it. And then we're going to move along. Excellent. So let's continue. The cylindrical container shown in the diagram below is, oh, you get 3,000, Lovey. It will be 30. Because you know why? 4 times 5 is 20, which adds another 0. And then when you multiply that by 2, yeah, okay. The cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. You see it now, Lovey? Okay, good. To fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 centimeters and a height of 21 centimeters. So everybody understand what's going on here so far? So they're telling us they got a bigger tank, boom, and they're using the smaller container to fill up the tank. Look at the shapes. This shape is a cylinder, whereas this shape is a rectangle. You know, one of the things I don't watch, are the units the same? Because you cannot work with two objects and if they don't have the same units. Everybody following? So luckily for us in this example, this got centimeters and this dealing with centimeters. So we don't have to worry about that. So what does the question want? All the water in this container is added to the water in the regular tank. Calculate the total amount of water now in the rectangular tank. That's easy. Do we know what to do that? We don't know how much water in the tank already because we done calculated in the previous question. Agree or disagree? Because I need to make sure y'all with me. So we know how much in the tank at the moment. So the total means to do what? Find the volume of this container and what operation do we need to do with those two figures? Once I find the volume of this container, what do I do with it? Do I multiply it to the 30,000, subtract it, add it? What do we do? Hello? Y'all hear me? What do we do? I'm waiting to hear what's the operation. If we're looking for the total volume, what are we doing? Thank you, Gwen. Yes, we got to add. So let's first of all find the volume of this. What's the volume? You realize these shapes keep coming back. Volume is the area of the cross section times the height. And we know the area of a circle is what? Pi r square times h. So this is just a simple substitution question. Oh, but they tell us which type of pi to use. Yeah, remember that? Where it is. Did they tell us which pi to use in this question? Yes. You see, we must use pi as 22/7. Please always back check to see if they tell you which pi to use, okay? So because they tell us to use pi as 22/7, this is how it's going to look. 22/7 times, what is r? 20 square times what? 21. As a good math student, anything here would make sense to cancel out? Which two numbers could cancel out? 7 and 21. Look at it. 7 can go into itself once. 7 can go into 21 3 times. So what you're going to end up with? 22 times 20 square times 3. Honestly, even if you do it the long way, you would have still get the same thing. Everybody with me? So look at it here. Even if you work it out the long way, you would have still get the same thing. So now that we find the volume of the container, we don't forget the purpose of finding it. The total water in the tank now is when we add the water in the tank already plus the water of one container. Let me know if you got it, please. Let me know if you got it, because we're moving along quickly. And to be honest, based on what we've done so far, these questions ain't so hard. Be honest, are they hard to you? Because to me, they're not hard. I was expecting it to be more like horrible, which is confusing. But how is it to you? It ain't so hard, right? Once you know your formulas. All right, so let's look at the third question. Me too, I was expecting this to be a traumatic experience. So there we go. C. Show that the depth of the water in the rectangle is 28.2 centimeters. Anybody know what to do there? So let's go back to the container. After you add it, find the depth. What is another letter to represent depth? Let me see who's thinking. If they want to know how deep the water is, what letter are you really looking for? Excellent. Everybody agree with that? Talk to me if you realize what's going on. Because remember, you have now a new volume. We have a new volume. So what they're telling us is the volume in the container is now this one after you add the new water, 56400, right? What do we remember? Volume is equal to length times base times height. Now, obviously, the water has risen because if you throw more water inside the container, the height gone up. So which two dimensions did not change? Which two numbers did not change? The 40 and the 50. No problem. So everybody, what you do, you substitute. So you know 56400 is equal to what? 40 times 50 times h. And what is the next step now? What do we do next? Transpose. So multiply what you can multiply. So let's work it out quickly. Y'all have your calculators. 40 times 50 is 2000, right? So 2000 times h. How do we find h? We divide by what? 2000 on both sides. So let's go and look at the working. Wait, this is another question, sorry. Look at here. Everybody with me? The only thing they didn't do is just multiply these two things first, which is the same thing as saying 56400 divided by 2000. So I just need everybody to confirm if they're following. So to be honest, as we see here, question 6 is not even so bad. All right, let's look at the last question. And look how short these questions is. You realize how short question 6 are? Question 6 are like so short compared to the other questions. Because look, we almost done another question here already. So let's read what we have. The vertical height, definitely. The vertical height of the rectangular tank is 48 centimeters. Determine how many more cylindrical containers of water must be poured. Now, this is a question. No, this is a question. So let me read it again. The vertical height of the rectangular tank is 48 centimeters. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. Anybody realize what it's telling us now? This is the total height of the container. So look at it. They're telling us now, they actually finally tell us the height of the container. So what do you think the first step is going to be? And to find out what volume the container could hold in all. The total volume of the container. So we know that's, again, the volume of the container is length times width times height. And we know that's 40 times 50. And what did they say the height was? They said the height was what? 48 times 48. So once you find that, that is going to tell us the total amount of water that can hold in the tank. But we know how much the water having so far. This is what we calculated before. So what do you think you're going to do to find out how much more it need? You're going to do what with those two numbers? Subtract them. Because if this is how much water the container hold when it's full, this is how much water the container has at the moment. To find out how much more it needs, you subtract. And that's how we get this answer here. So what did they ask for? So the number of cylinders. So how do we find how much cylinders now? Because this is just one part of the question. They asked how many containers can be used to fill it up. Don't we know how much volume is one container? We found that already. One container is 26,000. So to find out how much containers we need, what are we going to do with them two numbers? Divide. Right or wrong? This is how much more water it needs. And to find out how much cups, you just divide this by how much the one container holds. And they're going to tell you how much containers is needed. And that would be 1.5 containers to fill the tank. Yeah? How are we feeling? And guess what? That's it. That's the entire question. So we're going to keep moving. Look how short this next question is. So y'all ready? Because like I said before, today is going to be a short class. We are already on question number 3. And we see how straight to the point these questions are. So tomorrow is question 8. No, question 8 is a lot more difficult. It's something where it involves functions, relations, and graph and advanced algebra, but we got this. So let's take a look at this question. Farmer Brown makes, when I look at this shape, I see some complex things. Anybody realizing the complexity of this one? This ain't just a regular box, because what do you realize? The box has a thickness. So there's an inner box inside of the outer box, to see in our more simple terms. So let's read what we have here. Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. And remember, we always make sure the information is represented in the diagram. So we see here the 5 centimeters as shown in the diagram below. The troughs are rectangular based, which means the bottom of it, even though we can't see, I just want to make sure I show y'all. Something like that. We can't really see it, but you know what I mean? Y'all with me? That the base, even though it looking kind of weird, because there's an inner box, so yeah. So there's a rectangle base in the back here, inside here, as shown in the diagram. Open at the top and have external dimension. And I want you to realize this. You realize what word they use here? What is the most important word they use here? External dimensions. Do you agree or disagree? Because what do you realize? How is this going to affect the volume of the box? It means then that you can't use these numbers for the volume of the box, because the outer part of the box does not represent the inner section of the box. I hope you are following what I'm trying to show you. Outside is different from the inside, yes. And it gives us here open at the top of the box, we have external dimensions, 300 centimeters, 190 centimeters, and 60 centimeters. So the first question says, show. You know, anytime they tell you show, it means that they gave you the answers already. You just got to do the workings to prove that that's what you're going to get when you calculate it. Everybody understand the difference? So they want you to show the working out. Yes. So show by calculation that the internal capacity, which is the same thing as volume, and you realize what word they use again? Internal capacity versus the external dimensions. They do this so that you know you're not supposed to use the same measurements for inside and outside. So they want to find proof that the volume is this amount. Now let me ask you a question. How do we find volume again? Volume is equal to what? Length times width times height. I want y'all to tell me, what is the length? If the outside length is 300, what is the internal length? Let me use yellow. Let me see if you are thinking. What is the internal length? Everybody take a try. So Janella thinks it's 150. Anybody else? 150? Look at the yellow line. Look at the yellow line. The length. Where y'all get 150 from? Mel thinks it's 250. Try again. Because I don't want to spoon feed her everything. I need y'all to try. Try again. Look at the yellow line. Let me zoom in a little bit. And this is what I want you to be thinking. If from here, I'm going to use the red. If from here, everybody following me? From here to outside here is 300. Look at where the internal line is. What is the internal line? What is the difference between this space and this space? So how much we need to subtract? What is the difference from this space to this space? Oh, so let's try again. What is the length of the internal length, the yellow line? So Gwen thinks it's 280. Janetta thinks 290. Come on, everybody. We have a small class today. 295. I'm going to take whatever you give me because I want you to trace it. Remember, the 5 must be taken off on both sides. You ain't agree? Look at it. So you got to take off is 300, right or wrong, minus the 5 on the left, minus the 5 on the right. So how much you really minusing? Ain't 10. So it's 300 minus 10. This year, this exam, this question was done horribly. But everybody seeing what you're seeing now? You're seeing it now? So if based on our dimensions, let's go. So we shouldn't get the next one wrong. Length is 290. What is the width? So let me erase this. Come on, everybody. And I'm not telling you which one you should be looking at. What is the width? Let's go, guys. Let's go. Try. You got to be thinking. You got to be trying. You got 2 options to be looking at. Either the 190 or the 160. Which one you're going to look at? That's it. It is going to be 190, 180. Because look at it again. The entire width of the box is 190. But what do we realize? Ain't the same thing. Look at the internal width. What you're realizing about the internal width? That they on the side, let me use the red again. On the side, how much is this space here? Dying 5. You got to take out 5. From here to here, dying 5 as well. So it's going to be what? 190 minus 10 again. So that's going to give me 180. Everybody see that? And the last one that we need is the height. What's the height? Uh-huh. Excellent. Wait, you sure? Think about it, Remember the wood. There's wood on the bottom. Is there any wood to the top? So think about it, guys, before I tell you, think about it again. Remember the wood is 5 centimeters thick. So you do have a piece of wood to the bottom, but to the top, is there any wood to the top taking off, changing the height? So for the height, how much you gonna subtract? Ain't just 5. Okay. Okay. Everybody see what we're dealing with? Look at it here. These are the and yet look at it. You know what they say? With no cover. Something they say with an open top. Open at the top. Open at the top means there's no wood to the top, no thickness to the top. You see, they don't tell you things for no reason. They tell you these things to help you realize how to go about it. And there's a reason why they show us inside here. They show us that to tell us that there's a bottom. So that means the wood going across here is this thickness to the bottom here. Everybody with me? So we have our internal length, internal width, internal height. And as we know, volume is length times width times height. So the difficulty here wasn't even the calculations. The difficulty here was understanding how the thickness of the wood will impact the volume, the internal volume. And I hope everybody here understand, because questions like this come back a lot. This whole wooden box thing does come back a lot. So I hope everybody following. All right, next one. Calculate the volume of wood needed to make the trough. Now this is a whole extra one. How do you find the volume to make the trough? What do you need? If you want to find out the volume, which one you're going to use? In the external, because it's the actual box you're making. So that will give us the external dimensions. Everybody following me? Talk to me. Make sure you understand the difference between the internal volume and the external volume. So what we see here, you realize they use the external measurements, external volume of the trough. All right, so on the last question now. Wait there. Oh, they didn't ask us for the entire volume of the entire space with the box. So even this here tricked me. My mother's here. Look at this. The true volume of wood ain't just this sections here. The volume of this sections here. The gray area plus the bottom. So everybody realize what you really need to do? You need to take the volume of the outside box and subtract the empty space, which is the inside box, to get the volume of the wood itself. It's almost like saying this. Suppose I give you this shape. Suppose I give you 2 rectangles. This does come a lot. And I tell you, find the area of the shaded region. And the shaded region is outside here. How would you find the area of that space there, that shaded region? What do you do? I'm just making sure y'all understand the concept. How do you find the area of the shaded region? Step 1, wouldn't you find the area of the biggest space, the rectangle first? Then what would you do next? Find the area of the smaller shape inside that missing. What you're going to do with 2 of them? You're going to say area of bigger shape minus area of smaller shape. Because it's almost like you're taking out this empty space here, which is why we subtract it. If you got it, say got it. Because once you got it, we move right along. If you don't got it, tell me no. Okay, don't. Okay. Let's say I have a sheet of paper. Right, Natalia? And I ask you, okay, what's the volume of this sheet of paper? What would you do? You would just say length times width. Agree or disagree? So you would say length times width, right? You would just find the area. Suppose I cut a hole inside the paper. If I cut a hole inside the paper and I tell you, find the area of the shape that's left back. If this is an empty space, the area left back in wouldn't be the area of the paper minus the area of the hole. To find out what is the area of the paper that's left back. You with me? It's the same exact concept, but more advanced. So if you look at this, we have an outer box, because remember, it's wood, eh? This is an actual wood. You have an inner box, which represents this empty space. You seen it? Then you have the outer section of the box, and in between is the actual wood. So in between this space is the actual wood. They want us to find the area of the wood. So how do we do that? We take the area of the bigger section and minus the area of the whole to find out the shaded region, which would be the actual area volume of the wood. That's all that happened here. That was what was done. Okay? And if you see here, they explain it. Hence, volume of the wood used to make the trough external volume minus internal volume. Very good. Last question. And I think we only got 2 more questions and that's it for class tonight. Farmer Brown must paint the internal surface of the trough. I hope anybody know what topic this is already. If you see the word surface, what word should come to your mind already? A surface area? Talk to me. So given that 1 gallon of paint covers this amount of surface, and you realize what units is, this is area. So this is how much area this gallon of paint could cover. Determine the total amount of paint in liters, and keep in mind what units they gave us. They gave us centimeters square. But they're asking us for the answer in meters. You see the stressful part? That's the only stressful part. Luckily for us, what did CXC do? CXC tell us the conversion. That 1 gallon is this amount in liters. So find your answers in gallon and just convert it to liters. So let's take this step by step. So first thing first, we know how much paint is in 1 gallon. This is the space. But what should we do to determine how much paint we need and determine how much surface area we have? Yeah? So that means we need to find the internal surface area. So let's look at it. Now, the hard part about this is visualizing these things. So what we got to do is imagine this internal box. How many faces does this internal box have? Let me see who's thinking. How many faces does the internal box have that we need to paint? How many faces we painting? And I'm not moving on until I get an answer. So we need to try. So Mel says 5. What about everybody else? Natalia says 5. Janella says 5. Gwen and Nile, what do you guys think? How many faces or surfaces represent the internal space that would be painted? Okay, now check this out. Based on what we're seeing, we know there's a left, that's 1. And we know there's a right, even though we're not seeing it. Everybody with me so far? We know inside there's a back, that's 3. And inside there's a front, that's 4. And there's also a bottom, so that's 5. So it's 5 different areas we need to find. Luckily for us, which to match in? Wouldn't the left and the right match? So once we find the area for the left, we multiply it by 2. Once we find the front, we multiply it by 2. And then the bottom would be separate. Now, guess what is the more challenging part about this? Using the correct dimension. So let's look at the left and right. What are the dimensions for the left and the right? Because these are the things students don't ever struggle with. What are the dimensions for the left and the right? We did it already, eh? What is the width and the height? Let me see if I could draw it out so you could see. It's almost like you're saying it looked like this a little bit, right? Let's pretend that's how it looked. So what dimension should we be using in the internal measurements that we found before? So that would be what? 180 and what? 180 and 155. Agree or disagree? So once we multiply the length times that width, we multiply it by 2 for the left and right. For the back, anybody, what is the dimensions for the front and the back? Let me see if we're thinking. What are the dimensions for the front and the back? Those are the 2 for the front and the back, not the bottom, the front and the back. So it would definitely be 290 because we already agree that this line here is 290. We subtract the 5 thickness and the 5 thickness from both sides. But what is the other one we need? That's the length. What is the other one that we need? What is this measurement here? How much is the height? We just use it, 155. Excellent. Now let's see if we're thinking, what is the base? What's the measurements for the base? The internal base. Very good, because you're going to be 180. Very good. 180 and what? 390 or 290? Very good. Everybody agree or disagree? And honestly, that's it. Look at it here. And all you got to do, 2 times this, just like what we spoke about, 2 times that and the bottom. You add them up, boom. That's your answer. But this is not the final answer. This is just how much space is needed. Hello, you with me? This is how much area it has. Now, how do we determine how much gallons of paint is needed? 1 gallon is what? 280,000. So to find out how much of them we need, just like what we did before, what do? You divide. Now this here, they did it in 2 steps. I would not do this in 2 steps. What I would do first is find out how much gallons is needed. So somebody for me, hold on there. Let's make sure everybody understand. So pretend like this part ain't here. Everybody with me? So this part is us finding out how much gallons we need. Everybody see why? Remember, they told us 1 gallon of paint is this amount of centimeters cube. So we need to find out how much buckets we need. So when you divide that, somebody got a calculator, tell me how much you get. Anybody? Somebody, anybody, somebody. What are you guys doing? Okay, so we end up with 0, Jesus, the whole decimal there? Yes, no problem. So 0.7068. I think, is that right? So that means we ain't even using a full gallon. Anybody realize that? We're using a portion of a gallon. But they didn't ask us for the answer in gallons. They asked for the answer in what? Liters. So we know if 1 gallon is this, 0.7 gallon, you do what? 1 gallon is that. What do? We gotta multiply by this number here. Remember that? Everybody remember that? Once you find out how much it is, you multiply by the liters to convert. And guess what? That's it. We finish with another question. So this is our last question. Well, we got 2 more. But I'm only doing these 2. I have a serious migraine, so I'm literally pushing as much as I can. So let's do this one quickly. But while we continue, everybody following?